to talk a little bit more about ratios and review a little bit of what we've gone over real quickly, and then talk about something called equivalent ratios. And equivalent means two things that are the same, just look a little different, but they're exactly the same. They're equal. And we'll talk about that. So let's go over what ratios are first of all. Remember, the definition of ratios has to do with comparing two quantities using division. Now, we've shied away from the division part of the definition up to this point. This is where we're going to kind of veer into that area. So don't freak out. It's not hard, not complicated. We're taking it very slow with that division part, okay, so to keep you from being confused. So let's first talk about ratios. Now, we've talked about you finding ratios with models, okay? Not the, oh, a model. No, like, unfortunately, squares and triangles and all that kind of stuff. So, once again, some awesome drawing. Okay, there's the model. If we wanted to find the ratio of rectangles to triangles, we'd be able to do that. Remember, whatever they ask for first is what the first part of the ratio is. So since I'm asking about rectangles, we look at the rectangles. There's 3 of them. Remember, we've got our colon, and then a ratio of rectangles to, remember this means 2, triangles. How many triangles do we have? 4. So the ratio of rectangles to triangles is 3 to 4. And we also talked about the 3 different ways that you can write it. This is the most common way. You can write it out in words, or you can use our old friend fractions, which you guys love fractions. I know you love fractions. You can't get enough of them, and this is why you're going to be so awesome at it. That's sarcasm in case you hadn't done that, because I know you hate fractions. But here is the fraction way as well. And remember that the first number is always the numerator, the second number is always the denominator. Okay? So that is kind of the review of what we talked about so far in the other videos about ratios. So let's focus on the fraction part of the ratio, because that's going to be the easiest part to explain what equivalent ratios have to do with. Okay? So sometimes you have some ratios, like 3/4, and it's just like simplifying fractions, equivalent ratios, because remember, ratios can be written like a fraction. Okay, so this is the ratio of 3 to 4. Okay, now look at this ratio. Okay, that's a ratio as well. Put our little comma there, separate them. Okay, 12 to 16, that is a ratio. Now, these may look different, but they're actually the same. Now, remember back when you were dealing with fractions that sometimes you would have a fraction like this and you had to simplify it. That's basically all we're doing. We're going back and we're simplifying it, except we're doing it in the way of talking to them about ratios instead of fractions. Okay? So we're simplifying them just a little bit. So what we're doing with a ratio is, let's get rid of this one, because that one is simplified, is we're looking at this. And we're thinking of this the same way we would with simplifying fractions, is we look and see, is there a number that we can divide both the numerator and the denominator by that will make that smaller? We'll simplify that ratio basically. So we look at this and we think, okay, what can go into both 12 and 16? Well, of course, 4 can go into both of those. So we divide both the numerator and the denominator by 4. Twelve divided by 4 is 3. 16 divided by 4 is 4. And remember, I said that when I had 3/4 here, that both of 3/4 and 12/16 are equal. They're equivalent ratios. Look at that. So it's kind of a throwback going back to simplifying fractions, which, like I said, you love fractions, so it shouldn't be hard. But you should have some experience with this when finding out equivalent ratios. It's basically just writing the ratios as a fraction and then simplifying them and making sure that, okay, the 2 that they give you, are they equivalent? So let me give you a couple. So I'm giving you the ratio of 5 to 10. And We want to find out if this is true. And 35 to 16. Now, are these equivalent ratios? So what you have to do is you have to simplify both of them or get them to be alike. Okay? So if we simplify this one, what can go into both of those? Well, 5 can go into both of those. So if I divide this by 5, I get 1. This by 5, I get 2. This one I look and see, is there anything that can go into both of those? And I look at that and I think, no, there's not. It can't be simplified. So if it can't be simplified, is this the same as this? Absolutely not. So that means it's not equivalent. They're not equivalent. Okay? Sometimes they'll give you two fractions or two ratios. Sorry, we're in the ratio land. In the whimsical world of ratio land, where fractions are called ratios. Okay, so we're going to talk about them as ratios. If they give you two ratios and they ask you, okay, are these equivalent? Are they the same? You have to simplify one or both of them to see if they are equal. If they're both equal, then yes, they're equivalent. Okay, one other thing I want to show you real quickly. Remember I showed you earlier in one of the other videos of sometimes they would give you a chart much like this. And the example that I had were flowers to vases. Okay? And what they may do is they're going to give you a ratio in this. They may not even label the ratio. They may just give you a chart and it doesn't give you, it may just look like this. But they will give you something, say, for example, maybe 3 to 7. The ratio 3 to 7. So, now that wouldn't work with flowers and vases. How about 7 to 3? 7 flowers to 3 vases. Sorry. Okay? So the ratio is 7 to 3. Okay? Because you couldn't put three flowers in 7 vases. That'd be weird. So, let's make it a little simpler. I don't want to confuse you. Let's do 7 to 1. Okay? That way we keep it simple. All right? Let's not go with that route. I'm getting a little crazy, getting a little nuts. So we got to slow it back down. All right, let's do the ratio of 7 to 1. So maybe the flowers, 7 flowers of every vase. Okay? So what you'd have to do is they'll give you this. Now before, they would fill in some of these blanks and you could figure them out. This one, they're going to give you anything. They're getting evil. They're blocking it all out. Okay? So 7 flowers each vase. So what if there were, let's figure out equivalent fractions. Let's say that the denominator is 2. Okay? So whatever this is, whatever I did to this one to make that a 2, I got to do to this one. Okay? To make an equivalent ratio. So what did I do to this 1? Well, I multiplied it by 2 to give me 2. So whatever I do to this one, I have to do to that one. Sound familiar with fractions, huh? But remember, we're in ratio land, ratio land. So since I multiplied this by 2, I've got to do the same to the top. That is an equivalent ratio. Okay? Let's say there's 3 vases. What did I do to this to make that? I multiplied it by 3. So I have to take this and multiply it by 3. Gives me 21. Once again, an equivalent ratio. And this should be something that's very familiar. And sometimes they will give you a chart without being labeled. So let's do that one. And sometimes without it being labeled is a little easier. So let's go to 5 to 3. Okay? And then you've got to figure out 2 more equivalent ratios that would work that way. And basically, all you have to remember is whatever I do to the top number, I have to do to the bottom number in this chart. So I could even start up here. So let's say I want to multiply 5 times 2 to give me 10 for the next one. But whatever I did to that, which was multiply 5 times 2 to get this, I've got to do this. So 3 times 2, 6. Let's say I want to multiply this one by 20. 5 times 20 is going to give me 100. Okay, whatever I did to this, which was multiplied by 20, I have to do this. So 20 times 3, 60. Still an equivalent ratio, just not simplified. Okay? Hopefully that clears things up, because basically all you're doing with equivalent ratios is you're putting it in the form that looks like a fraction, even though it's a ratio, looks like a fraction, and you're basically making sure that it's simplified or finding out if they're equal. That's all you do. And hopefully that helps and it's not confusing for you.